The last measure of dispersion is what we call the coefficient of variation. The coefficient of variation is the ratio of the standard deviation to its means expressed in percent. So the significance of knowing the coefficient of variation is to compare dispersion of two or more data sets with different units. So to calculate coefficient of variation, we simply divide the mean from its standard deviation times 100%. So for instance, we try to compare the standard deviation between these three persons. Okay, for Anna, the standard deviation is 1.87, then the mean is 14. So we just simply divide the standard deviation and mean, then we have 13.36%. Then for Fe, okay, the standard deviation is 4.41 and the mean is 14. So 4.41 divided by 14 times 100%, so we have 31.5%. For Ben, so the coefficient of variation is 0% since all the scores are the same. So now we try to compare the calculated coefficient of variation. So for Anna, 13.36%. For Fe, 31.5%. For Ben, we have 0%. Then we can now conclude that among the three, Fe has the most spread scores since he has the highest coefficient of variation. On the other hand, Ben is the most consistent one because he has the lowest coefficient of variation. So that's the use of the coefficient of variation. Now we move to skewness or measures of skewness. Skewness refer to the symmetry or asymmetry of the distribution. Okay, so its measure can be obtained by using this formula, alternative Pearson's mode skewness coefficient formula. So it is calculated by multiplying the difference between the mean and the median by 3 divided by standard deviation. So there are two properties of skewness. We have symmetrical and asymmetrical. Symmetrical when the mean, median, and mode stays at the center of the distribution. That's why recently we called it averages. The mean, median, and mode are average because they stays at the center of the distribution. Asymmetrical when the distribution is skewed, and there are two properties. We have positively skewed and negatively skewed. When do we say that the distribution is positive skewed? When the mean is greater than the median. But if the mean is less than the median, then we call it negatively skewed. So this is the visual representation of skewness. So we have symmetrical when the mean, median, and mode stays at the center of the distribution. Okay, so this is what we call it averages. But when the mean is greater than the median, it is positively skewed. The bulk distribution is on the left. In other words, there are a lot of low scores in this distribution. But when it is negatively skewed, the mean is less than the median. In other words, there are a lot of high scores in this distribution. So when the computed skewness is 0, the distribution is normal. So it is called only normal or 0 when the mean and median are equal. But if the skewness is greater than 0, then skewed to the right or positively skewed. Okay, so there are a lot of low scores in this particular distribution. On the other hand, if it is less than 0, then it's skewed to the left or negatively skewed. So there are a lot of high scores in this distribution. So take a look on this example. We try to compute the coefficient of skewness of these three persons. Okay. Then for Anna, since the median and mode, the mean and median are equal, then of course the computed skewness is 0. So it's normally distributed. For Fe, it's 0.68, which is greater than 0. So the scores of Fe is positively skewed. So in other words, there are a lot of low scores of Fe. And then for Ben, is 0 all over 0. Since the computed mean is 14 and the median is 14, so we subtract that, then multiply by 3, that's 0. Then the standard deviation is also 0, so it's undefined. Okay. Next is kurtosis. Kurtosis is another measure of shape of a frequency curve. It is a Greek word which means bulginess. So it's the degree of thickness in the given distribution. So this is how we visualize measures of kurtosis. We have platykurtic, mesokurtic, and leptokurtic. For now, I'm going to show on how to calculate measure of skewness in Excel or spreadsheets. So for skewness, just simply type skew, open parenthesis, then drag the data, close parenthesis, and enter. So we have negative 1.14 for Anna. And then for Fe, just type skew, open, drag, close, so we have 0.552. And then for Ben, skew, drag the data, so we have undefined, so it cannot be. So since 0 divided by 0 is undefined. Okay. Then we notice that the value that we have computed a while ago is different from here in Excel. We have to take note that Excel make use of this formula, Fisher-Pearson standardized moment coefficient. And we don't like to see or use this kind of formula. Actually, it does not even appear in any elementary statistics. Okay? So better if we try to compute skewness using the formula that we had used a while ago. For thickness, okay, so we make use of this formula. Okay, kurtosis, then drag the data. So we have 2, okay, kurtosis, then drag this data. So we have negative 1.79. Then the measure of kurtosis for Ben. So it's also impossible. Okay. So why do we use this formula? Because when we try to navigate in Google, how do we make use of kurtosis? What is the formula for the computation for kurtosis? Okay, so this one, it's a little bit complicated. Okay, so we don't like to make use of this formula. Okay, so it's complicated. So that's why we prefer to generate the output here in Excel.